Hello students, welcome to the chapter differentiability. In this video, I am going to discuss about the function exponential function and logarithmic functions and their derivatives. So in mathematics, you learnt many functions like polynomial function, rational function, trigonometric functions. In the same way, you are going to learn a new function, exponential function and logarithmic function. Then these two functions derivatives. Now first let me discuss exponential function, how it is defined and about the exponential function and some features of exponential function. So exponential function is defined in this way. Exponential function is a mathematical function of the form f of x is equal to a raised to x, where x is variable and a greater than 1 constant. It may be any real number greater than 1 called base of the function. That is, if any function of this form a raised to x, where a is a constant, any number, x is a variable, it may be any number we can take, that is called as a variable, but a is any number we can take, but it should be constant. Then we change the values of x, so that is the function, and a should be greater than 1, and this is called base of this function. Okay, base of the function. For example, if the function is written f of x equal to 2 raised to x, here a is 2, x is variable. If I take, as I take values of x, any number, x is variable, it may be any real number. It may be negative, it may be fraction, it may be 0, it may be positive, or it may be any real number. There is no restriction on this x because it's a variable. So we can take any variable. This value or this function is defined. Okay, but a number base should be greater than 1. So this function is called now exponential function with base 2. Okay, and 3 raised to x and another function 5 raised to x, etc. We can write like this many functions, exponential functions. I hope you understood, students, what do you mean by exponential function. Next, you remember some points or some important features of this exponential function. The domain of the exponential function, that means what values of x we can take. You can take any real number here. This function is defined. That means when you substitute here any x number here, 0, negative, positive, and base number should be any greater than 1, the function gives you, when you operate that, you will get a real number or well defined number you will get. Therefore this function always well defined for any real number. Therefore we say that domain of the function is real numbers, set of real numbers. And the second point is the range of the exponential function. Means after operating this function, what are the numbers we get? See, we get only positive real numbers, set of all positive real numbers. That means you can take any x number here. If I operate this one, remember the output what we get, or after operating that function, whatever the real number we get, that is always positive real number. You cannot get here 0 answer for any x number or negative number for any x number. For any base it is. It may be the base 2, 3, 5, or maybe 10, 20, 30, whatever the base number, for any x number, we cannot get a zero answer or negative answer. Always you will get a positive answer. That is called as the range of this function. See, all these points you have to remember, or you should know about the exponential function. What is the domain of this function? What is the range of this function? You should know it very well. So next point is, the exponential function is always increasing function. So that means when you draw the graph of the function, always graph you will get in the increasing form. You never get in the down form. If you draw one from left to right, always it is upward direction. It never goes in a straight way, or it never bend, or never comes down. Always it is in the upward direction, that is increasing form. Okay, it may be any function like 2 raised to x, 3 raised to x, 5 raised to x, any base. Always when you draw the graph of the function, so it is always in increasing form. Therefore, what we say here, the exponential function is always increasing function. Okay, so next point is, for very large negative values of x, the exponential function is very close to 0. So here the behavior you see, if you take very large negative values of x, like for example, it is minus 1 lakh, minus, or it may be, it is very large negative number, then this function value is become very small. Very small means like 0.000 something. That means we say that it is very close to 0, because as I said, it never gives you 0 value. For any x number, always it is very close to 0 or more than 0. Okay, so this point you remember, for very large values of negative values of x, the function is very close to 0. For example, x is a minus 1 lakh, 2 raised to minus 1 lakh. This function gives you 0.00 something. That means it's very close to 0 number. I hope you understood exponential function definition and the functions examples, and about that exponential function. What is the domain? What is the range? What is the graph we get? Always increasing form. And then for negative large number, the function gives you very small number or very close to 0 number. Next, common exponential function. So common exponential function means the base, if I take 10 number. See, in previous just now I explained us, I gave some examples like 2 raised to x, 3 raised to x, 5 raised to x. All these are exponential functions. In this case, base is 2, 3 and 5. Now if I take the base is 10, then that exponential function is called common exponential function. Exponential function with base 10 is called common exponential function. That is, exponential function is a function f of x equal to 10 raised to x is called as a common exponential function. Okay. Next, natural exponential function. So suppose if the base is e, instead of 10, if e number, if I take exponential function with base e, where e is approximately equal to 2.71828, is called natural exponential function. Okay, if the base is e number, you know what is e called and what is its number. Its number is approximately 2.71828. That exponential function is called natural exponential function. That is, exponential function f of x is equal to e raised to x is called natural exponential function. So remember here, one important point I would like to discuss. this exponential function e raised to x, it is equivalent to one series form. Okay, that I am giving you now. The exponential function is equal to the series e raised to x is equal to 1 plus x square by 2 factorial, x cube by 3 factorial, x raised to 4 divided by 4 factorial, and so on. That means whatever x number here you take in the left side, if you operate e raised to that, okay, listen carefully, whatever x number you take, suppose if you take x is 0, then what is the value of e raised to 0? E raised to 0 is 1. Now in this series also you take x equal to 0, you will get one only answer because x is 0, 0, 0, 0 means all these terms become 0, 1 plus 0 means it is 1. Now you can see that we got the same number. Whatever x here you take, the same x here in this series you take and find the sum of the series up to infinity, you will get the same answer. Therefore, exponential function and this series both are equivalent. And this is very important result. Remember, it may help you anywhere. Okay. In a future, in some other topics, it may help you, or for competitive examination while solving the examples, it may help you. Exponential function and its series form. So let me discuss now the graph of exponential function e raised to x function. Okay, particularly this e raised to x I am discussing. So this is the coordinate axis. The graph of e raised to x you will get like this. And one more point before drawing the graph, it may be natural exponential function or any common exponential function, or it may be any other than base 10 and e, that is any other exponential function. For x value 0, any number raised to 0 is 1. That means for x is 0, the function value is 1. That means if you take any exponential function, if you draw the graph, the curve or the graph always passes through the point 0, 1. Any function, 10 raised to x, 20 raised to x, 3 raised to x, 2 raised to x, or maybe 15 raised to x, e raised to x, all these functions, graph or curve always passes through this point 0, 1, because any number raised to 0 is 1. Therefore this point always lies on any exponential function graph. Okay, so now this is the graph we get like this. For different values of x, you will get like this point. Okay, for 0 point, this is 1 point, and for positive number like this, we get a numbers or points function value. When you join all these points, the graph or shape of the curve you will get in this way. So that shape is drawn directly here. This is the shape or graph of the exponential function. Okay, here you remember how to draw it. Select 0, 1 point and then you draw a curve like this. That is the exponential function graph e raised to x. For different base, you will get in the same way but different position. Like it may be like this, one function, or maybe like this, and it never touches x-axis. As x is very large number, negative large number, this curve is very close to negative x-axis, but it never touches, because as I said, the range is more than 0 number. The point you will get more than 0, very close to 0, like 0.0005. It never gives the 0 value. That means it curve never touches this negative x-axis. Okay, so everything is explained here. So I hope you understood. So remember this point. The point 0, 1 always on the graph of exponential function, because a raised to 0 is 1 for any greater than a greater than 1 number. Okay, the meaning of this I hope you understood. For any exponential function, the curve is always passes through this 0, 1 point. So next is logarithmic function. So before logarithmic function definition, let me discuss some examples. Let me take some examples. Before definition of logarithmic function, let me discuss some problems or examples. We know that 5 square is 25. So here we say that logarithm of 25 to the base 5, logarithm of 25 number to the base 5 is 2. And it is written as log 25 to the base 5 equal to 2. Okay, I hope you understand. Whenever you have an equation like this, 5 square equal to 25, it is true, no? Then we say that whenever this equation we have, we say that log of 25, logarithm of 25, and base of the logarithm is 5, is this number, index. Okay, and this is written as log 25 to the base 5 is equal to 2. So therefore, logarithm is defined if we have this equation, this type of equation. Okay, let me take another example. That is 5 square equal to 25 implies log 25 to the base 5 is equal to 2. Similarly, if we have 3 raised to 4, you know that it is 81 equal. This implies log of 81 to the base 3 is 4 number. Another example, 4 square is 16. So what we say here, log 16 value to the base 4 is 2. Okay. So here remember, always logarithm of number value or answer is nothing but it is index of the base. Okay. And remember, if we have this form, logarithm form, then how to write its index form, like this equation. Both you have to remember. If we have this equation in terms of logarithm, if we have a logarithm form, then how to write its equation form. So both you have to remember, students. You have to understand how to write it in both the way. Okay, now I take a general form, then I define logarithmic function. Therefore, in general, if a, b, x be any three real numbers such that a raised to b is equal to x and a is greater than 1, then we say that logarithm of x. See what equation is taken here to define logarithmic definition. A raised to b is equal to x. Then what we say, log x number to the base a is b value and is written as log x to the base a equal to b. So this is only called logarithmic definition, or function means it is x is general, now it is a variable. Okay, then here we take y number or y, we denote that log x as a function, and base is a. So next, suppose if I take base is 10. So here the base is 4, base is 3. Suppose if the logarithmic base is 10, then it is called as a common logarithmic function, or common logarithm it is called. Okay, before common logarithm, so the same thing I write once again, a raised to b is equal to x implies log x to the base a is equal to b, a is greater than 1. Next is common logarithm. If base of the logarithm is 10, that is a number is 10, then logarithm is called common logarithm. That is log x to the base 10 is equal to b is called common logarithm. For example, log 100 to the base 10 is 2, because as you know that 10 square is 100, therefore log 100 to the base 10 is 2. As I said now, logarithm of number is nothing but index of this base. For which power you will get a 100 number. 2. 10 square is 100. No? Therefore, the logarithm of this 100 number with respect to this base 10 is 2. As base changes, this number will change. It may be any different number. So that it become equal to this number. Okay. Is called a common logarithm. Next is a natural logarithm. If the base is e if I take, then it is called as a natural logarithm. If base of the logarithm e, that is e equal to e, then logarithm is called natural logarithm. That is log x to the base e is equal to b is called natural logarithm. So natural logarithm is also written as simply log x, that is without writing base e. Here you can see that just it is a log x, base is not mentioned here. So which means that it is a natural logarithm, or ln x. ln x means logarithm of x number. Base is e only. Natural logarithm it is. This is also natural logarithm. And this natural logarithm only is considered as a logarithmic function in this chapter. That means we discuss log x function with base e function, with base e. Next, remember some points like what is the domain of this function, what is the range. Let me discuss. The domain of the logarithmic function is r plus set of all real numbers. That means in log x function we cannot take negative numbers, remember, and zero number. Logarithm is not defined. Only for positive number it is defined. Log is defined. Range of the logarithm function, it is any set of real numbers. After taking that number, whatever right side number we get, no answer, or logarithm value, that may be the any real number. It may be zero number, it may be negative number, or it may be positive number. It is any real number. That is range of this logarithmic function. Logarithmic function is always increasing function. Remember, this is also increasing. If you draw the graph from left to right, it is always moving upward direction, never in a straight way, or it never comes down. Ups and downs never you will get, only straight, increasing form. And the fourth point is for x very near to 0, because domain is a positive real number, as x is very close to 0, log x number is become very small number. That means log x gives a logarithm value gives you smaller number. And the fifth point is the point 1 comma 0 always on the graph of the logarithm function, any base of the logarithm. Remember, if I take x number 1, okay, x is 1. Remember, this one number we get if you take the, as I said, logarithm of the number is nothing but it is the power of the base. Now 1 we get if you take power is 0 for any number, because any number raised to 0 is 1. Therefore logarithm of 1 is how much? 0. Base may be any number. I hope you got it. If x is 1, base is any, this one answer or logarithm of 1 we get as a 0 value, because as I said, logarithm of the number is nothing but index of the base. Therefore, here one value you get if you take power 0 for any number, or if you take 0 power. Any number raised to 0 is 1. Therefore, any base logarithm, if you draw the graph, that graph always passing through 1 comma 0 point. It is just like exponential function. Listen carefully. Any base logarithm graph, it may be natural, it may be exponential, natural logarithm, common logarithm, or it may be any other base. If you draw the curve, then the curve or graph always passes through 1 comma 0. because for all that logarithm, if x is 1, then answer is 0 only. Therefore, the point is 1 comma 0. The curve should passes through 1 comma 0. Now see the graph of the logarithm function, that is log x to the base e. So consider a coordinate axis. Then as I said, 1 comma 0, it lies on positive x-axis, and 1 comma 0 point. Remember the curve, always the curve is passes through this point, any base, and the curve we will get like this, in this way, or in this shape we will get. So as I said, as x is very close to 0, means as x value is very close to 0, the function is very smaller number, very smaller, negative, higher negative value, that is a small number. Let me discuss both functions graph, that is the graph of exponential function and logarithmic function. Let me draw coordinate axis, and a point is selected 1 comma 0 on x-axis. Then this is the graph of log x function. To draw exponential, select one point on y-axis, that is a 1 0 comma 1, and this is the curve we get, or graph we get, exponential function. Now see students, these two curve, they are like mirror image of each other, reflected on the line y is equal to x. Okay, now let me draw, this is a y is equal to x function graph. With respect to this line, these two curve looks like a mirror image of each other. This curve mirror image is this curve mirror image with respect to this line is this. Okay, so this is a very interesting point here. You should remember these two curve like mirror image. That is the beauty of these two function. The exponential function and logarithmic function log x are the mirror images of each other reflected in the line f of x equal to x. Okay, so next is properties of logarithmic functions. In physics already you learned the properties of logarithmic functions, that is, if we have logarithm of product of two number, then it is written as log m plus log n. So this is the first property. Remember, these properties are very useful to solve the examples. Second is log m upon n. Suppose if you have a logarithm for division, then it is written as log m, that is numerator, minus log n, denominator. If you have a power like log of m raised to n, then this is written as n into log m. Okay, that power comes to product. And log m to the base n. Now base is n. In this case, the logarithm is written log m. Now base is not written, which means that here we can take any base. Here not written means it is e. Log m, actually we can take any base, log m, new base, log m divided by log n. Okay, here also you can select any base, same base what we take in the numerator, but we can take any selection, but not taken means it is a natural logarithm. So this formula is called change of base formula. Log m to the base n, it can be written as log m divided by log n. And the fifth one is log m to the base n. This can also be written as 1 divided by log n to the base n. That means interchange it. See, all these are equivalent. Okay, remember all these formulas which help you while solving examples. We use these properties and We simplify the function, we get a standard form, then we differentiate the function. So next is a derivative of exponential function. Now I am going to discuss what derivative answer we get for these functions. So far we discussed about the function, graph, domain, and then about that graph function. Next is what we get a derivative. So let me take this function as y equal to e raised to x, that is f of x. I differentiate, I find the derivative of this function using first principle, that is definition method. So differentiate this function with respect to x. So let me recall the first definition. If y is equal to f of x, then derivative is given by dy by dx equal to limit as h tends to 0 f of x plus h minus f of x divided by h. This should be exist. That means limit whatever exists, that answer is called as a derivative answer. Okay, now let me operate this first. Dy by dx is equal to limit as h tends to 0. Now you substitute f of x plus h. This is f of x, e raised to x. Here x is there, power x. Now x plus h means you take power x plus h. That is e to the power x plus h minus f of x means e raised to x divided by h. Now we have to evaluate this function. That means we have to find out the limit of the function as h tends to 0. Now you put h is 0 here, it become e raised to x minus e raised to x, that is 0, and denominator also 0. It is a indeterminate form we get. Therefore we cannot substitute h0 directly in this function. So what we have to do it now, we have to simplify this function. Otherwise we have to get one standard form. E raised to x plus h is written as e raised to x into e raised to h using laws of indices minus e raised to x divided by h. Okay, splitted here. Power is splitted. Plus is there, no, e raised to x and e raised to h. And you can see that e raised to x is a common in the numerator. So take it outside and it become e raised to h minus 1 divided by h. Now this is free from h term, because as h is tending to 0 means we have to consider here only h terms functions. So x is here, it is free from, take it outside and take a limit for this. And we have one standard limit in limit chapter. Limit as x tends to 0 e raised to x minus 1 divided by x, its always value is 1. So this is already you learnt in pu1 standard limits. So now this is also in the same form, but h is the variable, here x is variable, that is the difference. Whatever variable, but it is in the same form. Therefore what we say, limit of this function is 1. So that is the product is become dy by dx value e raised to x. That means e raised to x function derivative is same function, no changes, or it is not different function, it is the same function. Remember students. So whenever we are solving example, if you get e raised to x function, what is the derivative means you should write same thing, same function you have to write. Okay, for example sin x, what we write cos x, not different it is. But here e raised to x function, it is not different function, it is the same function, e raised to x only, no changes. I hope you understood how the limit is evaluated. And here this is one standard function, you remember. If you don't know, just you trying to understand this function limit value is 1, that's it. And the derivative of the function is e raised to x only. Next is derivative of logarithm function. So denote y is equal to log x, that is f of x. Differentiate this function with respect to x using first principle. So again recall that first principle formula. So find out the limit value. Dy by dx is equal to limit as h tends to 0. Substitute f of x plus h first term, that is log of x plus h minus log x divided by h. This term is f of x plus h minus f of x means log x divided by h. Now find out the limit value as h tends to 0. If h is 0 means it become log x minus log x divided by h means 0. Log x minus log x is 0. 0 upon 0 it is. So therefore we cannot substitute, or we cannot find limit here. So again we have to evaluate this function now. So now here we have a subtraction between log functions. So therefore using second property, this is written as log of x plus h divided by x. That means here log m minus log n. So by the property, what it is written, log m upon n, that is x plus h upon x divided by h as it is. Okay. Further, we cannot get limit value here. Further separating the function, it is 1 plus h upon x. See, if I separate this denominator, x upon x is cancelled and h upon x remains as it is, divided by h. And in the limit, we have one standard form, students, that log, this is the standard limit as x tends to 0, log of 1 plus x divided by x. Here you see, whatever this place is there, 1 plus x, that should be the denominator, and that term should be tending to 0. Then it is called as our limit of this function, we get always 1. As we have standard limit like sine theta upon theta as theta tends to 0, one number like that. Logarithm for log term, we have like this function, log 1 plus x divided by x, means whatever here this place term is there, that should be the denominator and that should be tending to 0. Then what is the limit answer? We get 1 answer. Here you see we have log 1 plus h upon x is there, but denominator only h is there. Therefore we have to adjust this denominator, like multiply and divide by x. This is the adjustment. I hope you understood why, how this x divided by x, why it is taken, because to get the standard form. Here you see x place is there, x denominator, therefore here h upon x is there. To get h upon x, this is the adjusted, x divided by x is taken. Now this is free from h term, take it outside. In the next step, dy by dx equal to 1 upon x is outside, and as I said, as h is tending to 0, remember students, whatever this term is, this term should be tending to 0. No, h is tending to 0, h upon x is also tending to 0, therefore we can change here limiting point. H upon x tending to 0, we can change it. Okay. Next is 1 upon x as it is, and this become now standard form like this. So therefore its derivative is, its limit is 1. Then what we get a dy by dx answer, it is 1 upon x. So therefore log x function means with base e. Understand, this is very important. Base of the logarithm is e. Then its derivative function is 1 upon x. That is 1 divided by this variable only, 1 upon x. I hope you understood what is the derivative of log x function. So next is if it is a composite, means e raised to x standard function, x variable. Now if we have a composite, then derivative is written followed like this, e raised to f of x derivative d by dx of e raised to f of x is written as, see, first you recall that e raised to x is written as same function, correct? In the same way, if we have any other variable, then it is written same function but into d by dx of composite variable, this f of x variable. Whatever function is given, that you write it into d by dx of composite variable, because this answer is because of this standard form derivative. E raised to x's answer is what? Same. Like that, if it is composite, same function. But into d by dx of composite. I hope you got it. Okay, I will otherwise I give one example. D by dx of e raised to 2x. It is written as e raised to 2x into d by dx of 2x. Same function, and then derivative of this power, that is composite variable. So what is the derivative of composite variable? 2x, it is a simple function. 2 as it is, x derivative is 1. So therefore e raised to 2x into 2 it is. So this is the solution or derivative of the given e raised to 2x function. So in this way you have to follow. And here you remember students, one shortcut formula I give you for this e raised to ax plus b form. That means linear function. E to the power, if you have e to the power any linear function, then derivative it is not required to follow like this stepwise. Directly you can write in this way. What is the x coefficient here? A number. Okay, e same function you write, then into a you take, that become direct answer. Okay, here also you can see that derivative of e raised to 2x is e raised to 2x, same function. What is x coefficient? 2. Write it 2. The same answer will get. This is the same answer. And the second one is same. It is, suppose b is 0, then it is a into e raised to ax. This is addition. For sometimes you will get 4x plus 3. 4x plus 3 means e to the power 4x plus 3 into 4, like that. Next is derivative of logarithmic composite. Log of f of x, if you have d by dx of log of f of x. So recall that log x function answer. What is the derivative answer? Log x, it is written as 1 upon x. See, this is x variable. In the answer we have 1 upon x variable. Suppose if this is f of x, then it is followed like this: 1 upon that same f of x but into d by dx of f of x. 1 upon f of x into d by dx of f of x. Okay, for example, d by dx of log 3x. How it is followed? 1 upon 3x. See here, this is variable. 3x is now variable, composite variable. 1 upon that variable 3x into d by dx of 3x. Next step, we have to differentiate that 3x. That is 3 into 1. And here 3 and 3 get cancelled. You will get 1 upon x answer. This is simplification answer. Now here also I would like to give you one important note. That is, if you have a derivative of log ax function, linear function, only ax form, then it is 1 upon x only. Because what happened here, when you write 1 upon ax into derivative of ax, it become a divided by a get cancelled, you will get directly 1 by x answer. Therefore no need of writing stepwise. When you have a function like this, log 4x, answer is 1 by x. Log 10x, 1 by x answer. Directly you can write. Otherwise, like this composite rule you follow and find out the derivative, you will get the same 1 by x answer only. Suppose if it is ax plus b form, 1 divided by ax plus b into a, 1 upon this variable into x coefficient, that is a. Like this you have to follow for addition if you have ax plus b. Now let me go for examples on exponential function. First, to become perfect on exponential function derivative, I take basic examples. If y is equal to 4x plus 3 into e raised to x, and remember students, now whatever the selection function is selected, it may be in the product form, but the function involved in that exponential, logarithm or division form, whatever the function, we follow the rule. If it is product, means product rule. Division, if you have division rule. And wherever the derivative of the exponential function comes, means you write the derivative answer. Okay, here you see I take one example. Y is equal to 4x plus 3 into e raised to x. then find dy by dx. Now this is simple example. Given function is 4x plus 3 into e raised to x. This is product of two function and standard functions. Product of two functions. So therefore we differentiate this using product rule. So let me recall, this is product rule. So we keep one function as it is, we differentiate the second one. Second function as it is, differentiate the first one. First function as it is, derivative of the second one plus second function as it is, d by dx of first one, that is 4x plus 3. Now wherever you have dy by dx or d by dx of the function, write it. Okay, now what is the d by dx of e raised to x? Exponential function derivative, it is same, and it is a standard x variable, same function, no composite rule, plus e raised to x as it is, d by dx of 4x plus 3, that is 4. Okay, 4x plus 3 e raised to x plus e raised to x, 4 e raised to x. Now here after differentiating we can simplify here, taking e raised to x common, then it becomes 4x plus 3 plus 4, second term common. So therefore what is the dy by dx we get? E raised to x 4x plus 7. So this is derivative of the given example or final answer. I hope you understood, students. Product rule using, we differentiate this one and then we simplify. Second one, if y is equal to, this is NCERT textbook example, e raised to x divided by sin x, then find dy by dx. Now first you write given function. See here we have function in the division form. Division form we have, therefore to write the differentiation or derivative of this function, we use quotient rule. Like this you have to identify always the given f of x. Division rule we follow. G function as it is, differentiate numerator f minus f as it is, differentiate g function, actually it is not fg, it is g function, and the whole divided by g square. I follow this denominator function, d by dx of numerator, that is e raised to x, minus e raised to x as it is, d by dx of denominator, that is sin x, whole divided by square of the denominator, that is sin x whole square. So next is wherever d by dx of function is there, you write it. E raised to x is e raised to x, sin x function answer is cos x, and this is sin square x, and e raised to x is common. So if taking common, you will get sin x minus cos x. First function coefficient is sin x, middle minus, and here neighborhood is cos x, whole divided by sin square x. And here further we cannot simplify, so keep the function as it is. I hope you understood how the rule is followed. If y is equal to cos x upon log x, as x tends to 0, x is greater than 0, then find dy by dx. Students, this is division function, so use the division rule again, but function is log x here, differentiate properly, and this example try yourself. Okay, this is a homework for you. If y is equal to e raised to 3x plus 2, then find dy by dx. Now I took a composite function of exponential. Write given function, differentiate with respect to x. Now recall that if it is d by dx of e raised to ax plus b, then how the answer is written. Same function and then into a. A means x coefficient. What is the x coefficient here? 3. Write 3 into same function. That is the answer, direct. In one line you can write the derivative of composite, but it should be linear. 4x 3x plus 2, linear function, power. If y is equal to e to the power 4 minus 5x, then find dy by dx. So write the given function, write the differentiate with respect to x. Now here recall that d by dx of e raised to ax plus b is written as a into e raised to ax plus b. What is a number? X coefficient. What is x coefficient here? Minus 5. So minus 5 into same function. So this is the derivative answer. I hope you understood, students. Thank you all.